Hello friends, welcome to our channel CBSE Science Lovers. So today we are with a important topic, that is evaporation. Evaporation, as you know, that the evaporation is an important surface phenomenon in which the liquid form of the water or any liquid material converted into its gaseous form just below any temperature below the boiling point. So what is evaporation, my dear students? Evaporation is the surface changing phenomena. Naturally, what happens? Generally, water continuously vaporizes at any temperature. So that vaporization is considered as an evaporation. Why? Because evaporation at atmospheric pressure, when the liquid form of the material converted into the gaseous form below the boiling point at any temperature, that phenomena is said to be the evaporation. For example, water, the liquid form of the water, when converted into vapor, just normally below boiling point at any temperature, that phenomena is said to be the evaporation. So student, what happens generally? Evaporation, why the evaporation we had at normal atmospheric pressure at any given temperature, matter particles, whether the liquid matter particles or the solid, in solid case the matter particles, or gaseous phase in matter particles, has the different amount of kinetic energy. For example, if you see the particles present, water particles present in this beaker, so the different particles has the different amount of energy. Mostly the surface particles, that surface particles comparatively has more kinetic energy with comparison to the inner particles, and when you go inside the system, then particular energy decreases. So these surface particles, just due to the more kinetic energy, they easily leave the system and evaporate. They easily leave the system and evaporate. So that phenomena is said to be evaporation. So my dear student, and that's why we say that evaporation is a surface phenomena. Why? Because here this phase changing procedure is happening from the surface of the system. The inner particles remain same. These surface particles can easily be overcome the interparticular force of other particles. They are comparatively feel less interparticular force because they are at the surface. So maximum part of these particles are in the atmosphere. So they require little bit less energy to leave the system, to vaporize, or we can say that to overcome the interparticular force by which they are bounding from the system, so that they easily evaporate. And this phenomena is generally said to be evaporation. Generally we say, we see that different rivers, ponds, and different water bodies during the summer season, they becomes drier. So where this water goes? Because this water evaporate. So evaporation phenomena held just below boiling point, at any temperature below boiling point. For example, if you see the water, then below 100 degrees Celsius at normal temperature and pressure and TP, this phenomena we had. So this is a natural phenomena. And the one thing is also, my dear student, evaporation causes cooling. Evaporation causes cooling. How the evaporation causes cooling? When these surface particles leave the system, so they take up or they borrowed the energy from the surroundings, from their surroundings, and decrease the surrounding temperature. For example, this A, B, C, three particles, they becomes evaporate. Then for the evaporation, the kinetic energy required, they borrowed some kinetic energy from their neighboring particles of the system. That's why the temperature of the system becomes decreases, and that's why it becomes cool. So when evaporation we had, the system particles when evaporate, then they take up the energy from their surroundings and decrease the surrounding temperature. That's why the evaporation also cause the cooling. In a general way, we have seen the cooling effect. Just see, when during the summer season, people sprinkle the water at hot surfaces or at hot roof, so that the latent heat of the vaporization just decreases the temperature of the surface and it becomes cool due to the evaporation. This is one simple example in which we are seeing that evaporation causes cooling. Sometimes what happens, just evaporation, due to the evaporation, you see different systems becomes cool. We just felt cool during summer season when we sweat up, हमको बहुत पसीना आता है. Then if we sit under the fan, then we felt cool. Why? Because at this time sweat fastly evaporate and take up the energy from our body surface, and then the temperature of our body surface becomes down, and that's why we felt the cool. So my dear student, evaporation cause cooling. Why? Because due to the evaporation, the evaporated surface particles take up the energy from their surroundings for evaporation, and that's why the surrounding system decreases and we get a cooling effect in the result. So that is about evaporation and its effect, cooling effect. So another thing, my dear students, what are the different factors on which the evaporation depend, or evaporation affected by which factors? So first of all, evaporation affected by the surface. Why? Because it's a surface phenomena, and that's why evaporation affected by the surface. How? Evaporation, rate of evaporation is directly proportional to the surface area. When you increase the surface, the rate of evaporation increases. Why? When the surface area increases, then the number of particles on the surface also increases and they easily evaporate. And that's why we can say that the rate of evaporation is directly proportional to the surface area of the system. For example, if you take up the water in a plate having this surface area, and if you take up water in a tumbler having that surface area, then from the plate water maximally evaporate. Why? Because in case of plate you are seeing maximum surface area, so maximum surface particles evaporate. But here in this case the surface area is very low, and that's why less number of surface particles evaporate. So we can easily observe that the rate of evaporation is high in this case, and this rate of evaporation is low in this case due to the surface area. So the rate of evaporation is directly proportional to the surface area. If you increase the surface area, rate of evaporation increases. Just see during the summer season, or when we kept the cloth for drying up, then we spread the cloths. Why we spread the cloths? So that they faster dried. Why? Because after spreading, the surface area of the cloths becomes increases, and that's why the evaporation increases from the cloths, from the wet cloths, and they dry up easily or faster. Second factor on which the rate of evaporation depends. So my dear students, second factor is the temperature. Temperature is another factor, and when you increase the temperature, then the particles got sufficient energy to evaporate. That's why when you increase the temperature, rate of evaporation increases. So we can say that the rate of evaporation directly proportional to the temperature. If you increase the temperature of the system, or the temperature of the surrounding increases, rate of evaporation B increases. Third factor on which the rate of evaporation depends, that is, my dear student, humidity. What is humidity? Humidity is the amount of water vapor in the air. Our surrounding can hold an optimum amount of the water vapor, not more than. So if the humidity is high, it means there is the sufficient water vapor in our surroundings. So there is no place for the water vapor. In this case, if the humidity is high, then the rate of vaporization also decreases. So we can say that rate of evaporation is inversely proportional to the humidity. It means when you increase the humidity, the rate of evaporation decreases. Why? Because if the humidity is more, then there is the sufficient amount of the water vapor in the air. So there is no more water vapor can hold by the surroundings. So the rate of evaporation further decreases. So my dear student, another factor on which the rate of evaporation will depend, that is the wind speed. Yes, wind speed. Have you observed when there is the high speed of wind blows, then the wet cloths dry up faster due to the high rate of evaporation. So the rate of evaporation is directly proportional to the wind speed. Wind speed, when the wind blows fastly, then it take out the water vapor with it, and there is the sufficient space to the upcoming water vapor from the system, and the rate of evaporation increases. So these are the different factors, my dear student, on which the evaporation depends. The first is surface. If you increase the surface, rate of evaporation increases. Means rate of evaporation is directly proportional to the surface area. Second one, temperature. If you increase the temperature, then the particles got sufficient amount of kinetic energy to evaporate. That's why we can say that the rate of evaporation is directly proportional to the temperature. Third one, humidity. Humidity is the amount present water vapor present in the air. So if already there is more water vapor in the surrounding, then there is no more water vapor can be release or hold by the surroundings. So in that case, the rate of evaporation will decreases. It means rate of evaporation is inversely proportional to the humidity. If you increase the humidity, rate of evaporation will decreases. And next factor, that is the wind speed. High speed wind just take up the water vapor from the surroundings, and there is the space to hold the upcoming water vapor by the evaporation. So the rate of evaporation will increases. So the rate of evaporation is directly proportional to the wind speed. If you increases the wind speed, then the rate of evaporation will increases. So that all are the factors which affected the rate of evaporation, my dear student. Another thing is, have you ever seen when you take the cool water in a glass, then the outer surface of the glass has small water droplets? What is the reason behind it? Just see, if you take the cold water, in a glass, then there is a small droplet suspended just the outer surface of the glass. This is due to the condensation, because the cold water decreases the temperature of their surrounding, and due to the decrease in temperature, the water vapor present in the surrounding airs becomes condensation becomes condensed and just suspend in the form of small tiny water droplets. So this is the observation. You can see these type of observation at your home. So my dear student, just see and learn by the doing. All these activities related to the evaporation you can see in your daily life. Watch our channel CBSE Science Lovers. Thank you.